Hi, this is Kyle Haynes with Technically Speaking at Source Allies. Today, we're going to talk about Spring AI, which is one of the newest members of kind of the Spring ecosystem that allows you to easily integrate with large language models. So you can think if you've been out to a website like ChatGPT and typed in and asked questions of those models, that's a website you can go to, but what if you want to use it in your own app? Spring AI's main goal is to make it very easy for application developers to interact with those models and kind of do it your own way instead of having to go out to some other website and view that information. So we've got a lot to get through, and let's get cracking. So a little bit agenda. Agenda for today is going to be to dive into Spring AI and talk about some AI concepts and kind of get a baseline for us. Then most of the time today we will be spending doing a demo. This is going to be starting off with simple interactions. How do we interface with these models in a quick way? Then we'll do prompts. How do we build up, comprise, and compose messages that we want to send to the models? Output parsing. How do we handle just not straight strings, not like a chat interface in and out, but instead work more on JSON and structured format so we can build an actual API? And then we're going to do some retrieval augmented generation, or RAG for short, which is how we interact with models when the models may not know the information that we have, right? Some models aren't trained on the information we might want to know about. So RAG is a way for us to interact with those models that'll let us get extra information. All right, Spring AI. So the Spring AI project's main goal is to make it easy for developers, like we said earlier, to interact with AI without unnecessary complexity. I really like that phrasing from their website where they describe it, because it reminds me of other things in the Spring ecosystem. So if you've been in the Spring ecosystem and you've done like Spring JDBC, that's how do I interact with the database without unnecessary complexity? And Spring AI is the same concept, but it is a newer project. So it was first committed to in GitHub in July of 2023. There were experimental tags. They sit in this incubator experimental kind of holding pattern for a while until they decide they want to keep moving forward with the project. And the experimental tags were removed in December, so a few months back, and currently we're in the 080 snapshot. So just as an FYI, we are demoing something today and talking about something today that is coming, and it is going to be cool, but it's probably not prod worthy yet. I wouldn't go using this, don't go talk to your boss tomorrow and say this is ready for prime time. A lot of things have changed in the last few months, and a lot of things are still changing, but it's a cool project that is coming, and we wanted to get that out here for you guys to see. So let's talk about AI concepts. We've got a couple slides here. The first one is AI models. Kind of like we were talking earlier, if you have interacted with ChatGPT or any of those similar websites, you have interacted with an AI model. These are just giant algorithms. They take text, some take images, some take voice, but they're giant models. They take those, they know how to handle them, and then give you some sort of best guess, a generated guess as an output. Spring AI, similar to like Spring JDBC, has a whole bunch of implementations behind the scenes. So you'll be able to take a common interface and you write to that interface, and then behind the scenes, Spring will handle the magic of whether or not I'm talking to Azure or Amazon or GCP or OpenAI or whoever I'm talking to. Spring makes this very, very easy for us. All right, the next concept here is prompts. Prompts are going to be the building blocks for how you want to talk to your model, right? So if you've typed into a text box for ChatGPT in the past, you have, whether or not you knew it, typed in a prompt. Prompts in your application code are ways that you can compose messages that maybe the user's asking, or maybe allowing you to put in some guardrails around what you want the models to behave, and they help you guide you towards the response you're looking for. Spring AI is helping, again, because not all the APIs you're going to talk to are going to require the same inputs, so we abstract that away. And they also have great templating support, so a lot of times you'll see prompts that are really big, long prompts, and Spring's got really good support for kind of putting in little template pieces into them and building them up programmatically. Next is retrieval augmented generation. We'll touch on this at the very end of the demo, but again, this is a concept or a way you program with AI where if the AI models don't have the data you need, you can provide it to the models. So for example, a lot of the models, like we'll be talking with ChatGPT or with GPT 3.5 today. When we talked to that model, it was only trained up through like September of 2019. So what if you want to ask it information about 2021 or 2022? it doesn't know that information. So you have to provide it to the model when you ask questions, and then the model can churn over what you've provided and provide intelligent responses. A lot of times this is used if you want to like chat over your documentation. So for example, I have a whole bunch of Confluence documentation or SharePoint documentation. How do I search that via these models? And RAG or retrieval augmented generation is a great way to do that. Spring AI gives us a lot of different implementations of vector storage. When you do this, you have to store all your data in a specific format to make it easier to work with in a vector storage database. And Spring's got a lot of great implementations. Again, all abstracted to the same common interface. All right, so let's talk about vector databases a little bit. So I didn't know a whole lot about vector databases until I started kind of digging into this a few months ago. The best example I can think of is really like this picture I found online of a vector database is a way you store your data. So you can think of like the example I like to use here is like if you think of like Wikipedia articles. If I was trying to store Wikipedia articles on dogs and wolves and cats, they would all kind of get grouped together in the same location, this like infinite spaced vector. Same with fruits, bananas and apples get grouped together. So you have this way of the models, you provide text to the model, and the model gives you back this vector, this like place in space where these things are at, and they're kind of grouped, similar things get grouped together. And that's what we'll use for our RAG demo towards the end. Everything will get grouped together, and we'll be able to take information and send it off, and hopefully we'll get the right responses back. All right, let's demo. All right, so what we're gonna do today is build a web app that is going to serve sports statistics. So I'm a big sports nerd. I'm a big Iowa Hawkeyes fan. Football season's a little bit past us now, but this will let us relive it, right? So we're going to build a web app that's going to do sports statistics. What we have here is our Gradle app. I'll be able to show some dependencies of what we've got. We're going to be using Java 21, the latest version of Spring Boot. We have Spring Boot Starter Web. This is going to let us build our REST APIs. And then we also have Spring AI, OpenAI, Spring Boot Starter, 080 Snapshot. So it's kind of a lot of words, but basically it means, hey, I want to use Spring AI. Behind the scenes, I want to talk to OpenAI, and I want to do it with Spring Boot, and this is the version. Oops, put that back. And that 080 Snapshot's the version we want to use. We also have Lombok in here, so hopefully we don't have to write quite as much code as we're running through things. All right, so that's our tech stack. We'll kind of run through these topics as we run through things here. All right, so just so we're all on the same page, here's where we're starting at. I've already got like a little REST controller here, so we should be able to, basically this code is allowing us to have a REST endpoint at /stats that we can send a post request to with a body, and we're just gonna log it and return the question we asked. So if I go in here to our Scratch file, IntelliJ's got really great HTTP support. We're gonna make a post request to that stats endpoint with a question: who led the Iowa Hawkeyes in touchdown passes in 2018? That's all we're going to try to do. Let me start it up. So we'll start up our server, and once that gets going, we should hit this and verify. We got a 200 back, and it just said, who led the Iowa Hawkeyes in touchdown passes in 2018? So we're not doing anything yet. We just have an endpoint that takes data and returns it. All right. So we say, how do we get that to answer the question for us? And that's kind of where Spring comes in. And again, they want to make this as easy as possible. So Spring has a concept of a chat client. And this is specific to Spring AI. You have a chat client. And if you want to chat with it, if you want to ask questions, do prompts, that kind of stuff, you use chat client to do that. So here's where we've got a hook to our question. We can just say chat client.call, and we give it our question. Oops, if I could type. Nope. All right, chat client.call, request that question. That's it. Again, they want to make this as easy as possible for you to get started and get cruising. That's basically it. And you're saying, Kyle, that's way too easy. And you're kind of right. The only other thing that you've got to do in here is we need a key. Spring has application properties for most things that you're going to want to do. This is no different. So if you set up an application property, Spring AI, OpenAI, API key, you have to have a key, right? So this is a managed service. You can go out to OpenAI's website. You can make an account. I made an account and I gave myself $10 via, like, you give your credit card info and you can kind of like fund your account instead of actually having it directly pull from your credit card, which is kind of nice. So I just gave it like $10, and I've been doing this demo a lot, and I think I've spent like $1.80 over 2 or 3 months. So it's relatively cheap for you to, if you want to get out there and play with it, just know that it's not going to break the bank too bad. But yeah, you would have your API key here. For the purposes of this demo, I have an environment variable called like Spring AI, OpenAI, API key, ABC123. So like my actual key is stored in my environment variables, just so we don't expose that. And then you can also do things like change your model that you want to talk to, things like that. All right, so with all that in place and you've got your key, we've got our chat client, we can make a call. Let's stop our app and start it back up, and I'll go back to our HTTP file here, and let's make that same request. Who led the Iowa Hawkeyes in touchdown passes in 2018? And in 2018, the Iowa Hawkeyes were led in touchdown passes by their quarterback, Nate Stanley, who threw 26 touchdown passes. Incredible stats. Go Hawks. All right, so that was pretty easy, right? Simple interactions. That took like 2 lines of code, and we were off to the races. It's great. Okay, so if you're going to do anything more than that, right? This is like the simplest approach. We're taking in a string, we're getting a string back. Everything's strings. Life's good. If you want to get farther and more in depth than that, we're going to start talking about prompts. So prompts, instead of strings, Spring AI has a concept called a user message. In all caps, user message, and equals new user message, and you give it your request dot question. So you can think of user message, it's pretty self-explanatory. This is the thing the user of your API or the user is kind of asking. We'll get into system messages in a little bit, but user messages for now are what we're going to worry about. And that user message can go into a prompt. So you have prompt, new prompt, and you can give it a list of, again, these are composed of a bunch of messages. So you can give it a list of messages, and we'll just give our user message as the only message we want in our prompt. I'm also going to log it out because we're going to want to see these later. Prompt. And we will put the prompt there so we can look at it after we call it. And that's the prompt. And then instead of sending our question in like we were doing earlier, we're just going to send the prompt in. And what that does is now that we're not just doing strings to strings, the API contract changes here, where instead of getting a string response, I believe we get a chat response. So we have this new thing called a chat response. And there's a lot of cool information on that. Things like how many tokens you used. So for those who haven't used or interacted with these models before, a lot of the way that you pay is based on how many tokens you use. And you can kind of think of tokens as like words. I don't think it's a one-to-one match, but it's similar. So for example, if I'm going to send a short sentence out to this model and get a short sentence back, I'm not using a lot of words. I'm not using a lot of tokens. But if I were to send it something like, here's 6 pages of a PDF or 6 pages of a book, convert it from English to Chinese for me and give it back. Like, obviously, that's a lot more words. It's a lot more processing. So you pay more based on usage rate. But that info is in here, so we can log that as well. So we could say, like, var tokens and chat response .get. So there's all these things off of it. There's some metadata. There's usages. And then you can get your whole token. So we can see how many total tokens we used. Maybe we can log that out as well. Tokens. I'm just putting these on new lines so they're easier for us to see when we get into the console. Okay, so there's our tokens. And then our actual string response, like we had before, is going to be chat response .get result, .get output, .get content. Pretty straightforward. Before it was a little nicer. It kind of abstracted this away from us. But again, if you wanted to do anything more than just really simple interactions, you need to go with these objects. So this code, the way we have it right now, I will stop and start it, but it should be exactly, to the end user, it should be the exact same thing. We just kind of like took easy route and we kind of expanded it out to go with prompts. So let's run that same thing. Nate Stanley, 26. Cool. All right. That is most of prompts. Now what's cool is we've got this new API, right? We have an API, it's sports stats related. We can ask it all kinds of sports stats questions. But what happens if I ask, like, what year did Java release? Java got released in 1995. Shoot, we don't want this, right? We want a sports stats API. We don't want just some random API that people can type whatever they want into and we just forward it on to some LLM out in the sky. So how do we fix that? We talked about user message. This is where system messages are going to come into play. So again, user message is what the user asks for. System message can be kind of the guardrails. How do we lock it down a little bit so not everybody's abusing our API? So we're going to make a string called system message text. Java has multi-line strings. I don't know if you guys knew that, but it's kind of cool now. And we're going to give it some guardrails. So we're going to say, you are an expert college football analyst answering questions about college. Oh my gosh, if I could type football. If the question provided is not about college football, simply reply, I don't know. Don't know. Cool. Okay, so this is our goal is to put these guardrails in. And we can, like we had a user message, we also have a concept of a system message. So we can have system message is new system message, and we give it some system message text. And when we just send that in to our prompt, and everything's hooked up. We already had the user message there. We're just going to tie in the system message. And let's see. Now with our guardrails in place, now we're back up. What year did Java release? I don't know. Oh, shoot. You used to know. Joking. All right. What year did who led the Hawkeyes in touchdown passes? I don't know. There you go. Nate Stanley, he threw for 26 touchdowns. All right, so I had a little typo there where I kind of typed this wrong. Again, this is when you're interacting with these large language models. There's a lot of work that goes into making sure your prompts are right. So if I just don't quite have this right, the model's going to get angry at me. So there's a lot of trial and error. They're pretty easy to get set up, but there's a lot of trial and error on making sure that you provide the exact right things to get what you're expecting back. That's a tough topic. All right. So we have an API that will give us information about who led the Hawkeyes in touchdown passes, and it won't tell us anything about Java, so that's cool. All right, let's go back to the README. We did prompts. Let's do templates. Okay, so we have this API that gives us all this awesome sports information, just sports information. But what if I want to know about the Kansas City Chiefs? In theory, if I punch this in, it's going to tell me I don't know, because it's an NFL team, right? It's not college football. So let's change our API. Maybe we have consumers that are really wanting us to do other sports, not just college football. So let's change it so our API has a sport attribute on it, and we can pass in a sport, and we'll have it obey to only answer about that sport. If we do that, we need to take our request, and instead of just taking a question, we also need to take in a string of the sport. And we also can start templating this. And so this is kind of earlier I was talking about templating. What we can do is we can take all these references to college football and kind of put a little placeholder in here, and we'll just call it sport. So we've got college football, and we'll call it sport, and we got college football here, and we'll replace it with sport. All right. With that in place, we have this template, and Spring gives us something called a system prompt template. A new system prompt template, and we can give it our text, kind of the template text that we want to use. And instead of building our system message this way, we're going to build a message and call it system message. And that is going to be system prompt template.create message. And it can take a map. So it takes in these variables, and it will build the message for us. So we can have the variable as sport, right? This sport is going to line up with the sport we have here. And we can pass in request.sport. And that's it. So this is going to build a new message for us that's got all these goodies in it. So let's stop it and start it back up. And let's see if this works for the Kansas City Chiefs. Kansas City Chiefs touchdown passes in 2018. Patrick Mahomes led the Kansas City Chiefs in touchdown passes in 2018. Just because I want to go look at it and we haven't shown it yet, I'm going to go scroll up and look at our request. So here's what we were logging out, the prompt. You can see our prompt is composed of that user message. Here's the question. And it's also composed of this system message about our expert NFL analyst information. And then you can see that we used on that request 70 tokens, and the response that came back was Patrick Mahomes in 2018. Awesome. That is templates. Now, what if we want to do something about who led the Kansas, let's try this. Who were the top 3 rushing leaders for the Kansas City Chiefs in 2018? I'm assuming this will work as well. Awesome. So we get this response. The top rushing leaders are Kareem Hunt, Patrick Mahomes, and Spencer Ware, and they've got all these yardages associated with them. So if this is us and we have this API, maybe we have consumers that are saying, hey, this is really great, but how do I parse this text, right? I want to take this text and I want to use it. I don't want to just show it on a screen in a text box. I want to build a table on a page. I want to build an API that can utilize what you've exposed here in your sports stats API. Parsing this is a nightmare, and it's not always going to be in the same format. So how do we make an API out of this? And Spring, again, with everything else, makes this very easy to do. You'll see what we're going to do is we're going to think of, instead of returning a string, we're going to return a new response object that we're going to build down here. So we have a stat request. Let's make a record called stat response, and it'll have maybe the name of the team that we had the stat is related to, and we can have a list of stat items maybe. And let's build a stat item as well, stat item, and maybe that'll have the string stat name. We'll have the string player name, who the stat is associated with. We can have the year it was associated with, and then maybe a float to represent the actual stat value, if that's rushing yards or touchdown passes and something like that. Okay, so when we've done that, let's change our response. We don't want to return a string anymore. We want to return a stat response object. And Spring allows or gives us this thing called a bean output parser. So we're going to build an output parser. New bean output parser. And what you do is you give this what you want the output to be, which is going to be a stat response dot class. That's it. We have this output parser. It does two things really well. It does two things really well. It will give us the format that we want the response to show up in, and it will actually parse it and do that parsing for us. So the first thing we need to do is, if we want the models to give us output in a specific format, we need to tell it that, right? So it won't give it to us in a format if we don't ask for it. So we're going to include a format chunk in our template now. In Spring, again, because they want to make everything very easy, we're going to include a format, and it's just this output parser dot get format. And Spring will automatically build this big thing, and we'll show you to you in a little second here, that automatically tells it the schema that we want our response object to be in. And then down here where our response was a string previously, we can do output parser dot parse and give it the response. And that's it. Again, super easy. I was kind of amazed the first time I did this about how easy this is, and we'll see if it works. So same request, who are the top 3 rushing leaders for the Chiefs in 2018? If we run that, remember before it was that string response? Now, look at that. We have JSON. So we've got a content type of application JSON returning from our API. The team name was the Kansas City Chiefs, and here's our stat items. We got Mahomes, rushing yards, 2018, this many. Kareem Hunt, 2018, that many. That's pretty cool, and we didn't do anything. As an application developer, we wrote very little code. What I do think is interesting here is I want to show you what we actually sent to the model. So here's our prompt. We have our user message about what the ask was, and then we have our system message. This is our big template we're building up, right? So here's the rules it needs to abide by. And then this extra thing, when we just typed in format above, we typed in wherever it was at, format. That format chunk turns into Behind the scenes, Spring is telling it, hey, your response should be in JSON format. Don't tell me any explanations, but only do an RFC 82059 compliant JSON response. And then it actually gives the schema. It says, here's the schema you need to adhere to. And it'll automatically spit out here, I need a stat items array, and I need it to have a player name and a stat name. And behind the scenes, the model is just magically smart enough to like take things that we know we want in our mind and shove it into the right values. And that's just insane crazy to me that it works this way. And the first time I saw it, I'm like, holy cow, that's kind of cool. So we've changed from a text-based, chat-based thing to now we can build an actual API. We can have consumers call this and expect the same responses time and time again every time. So that is super powerful, especially if you want to do an API on top of these large language models. Very, very cool. All right. That's output parsing. Let's talk about retrieval augmented generation, or RAG. Okay. The question we're going to ask is, who were the top 3 leaders, let's say leaders in total tackles for the Iowa Hawkeyes in 2023? And we're going to change this to college football. All right, so the model we're talking to right now is OpenAI's GPT 3.5, which was finished its training in 2019. So it doesn't have any idea who did this. So if we send this request right now, I think this gives me like some bogus like player A, player B, player C. Or it's like fake data is what it'll give me because it's trying to give the right info. Yeah, so here's player C had 90 tackles. Player B, this is all fake. This isn't real data. So how do we get it to give us the right answers? That's where retrieval augmented generation comes into play. So what we have to do is we have to have the data that we want, and we have to provide it to the model while we ask the questions. So I've went out to the Iowa Hawkeyes official sports website and grabbed a whole bunch of information about like, here's all the player names, and here's how many games they played, and here's all their rushing yards, and I've got all that for punts and kicking and field goals and defense. So defense is the thing we're going to be asking for, right? We're going to be asking about total tackles on defense, and the top 3 people are Jay Higgins, Nick Jackson, and Sebastian Castro with 155, 99, and 61 each. So that's the goal at the end of this, is we want that to spit that information out for us. So when we have that information, what we need to do first is store it. So we're going to have a database, a vector storage database. For the purposes of this, it's going to be like a file-based database. It's not an actual, like, we're not spinning up Postgre or something like that. We're going to write to a file. We'll show you what it looks like in a file. And then we'll use that file to send that information out to the model. It'll churn on it and send it back to us. So what we're going to do is we're going to build a new endpoint here that lets us generate and populate our data store, more or less. So we're going to build another post mapping, another post endpoint. It's just going to be void, and we'll call it generate embeddings. This needs to be at /embeddings. Okay, so now if we do /stats/embeddings and we send a post in, we'll hit this method instead of the other one down below. The first thing we need to do is to retrieve all the resources. Let me close this so we have a little more info. Retrieve all the resources, or these are the markdown files from class path. They're in the class path right now. I think if you were really going to do this, you'd probably set up a webhook, or you'd set up a batch job that every night I'm going to go scrape things. But just for this, we're just going to have an endpoint that does it. So we'll have something called var resources, and that is going to be equal to resource pattern utils dot get resource pattern resolver. This takes in a resource loader, so let's go get one. Resource loader. And then we can get resources given like a pattern, because this is resource pattern utils. These are all at class path documents /star.md. And we'll just add the exception to our method signature. So basically, this is going to go find every document in our documents that ends or it starts with a star.md as the file name. So it should pick up all of these markdown files for us. And now that we've got those, we need to convert them. So we need to convert to Spring AI documents. So documents are what gets stored in our vector storage database. So we'll make a list of documents, new array list, and we'll import Spring AI's document. Okay, now we're going to iterate over resources, resources.iter. So we're going to loop through each of the resources, and this is another spot where Spring AI gives us some pretty cool things. We have text files. We have markdown files is what we have right now. So Spring AI has support for reading in text files. They also have JSON support, and I believe PDF support is coming as well. So if you have a whole bunch of PDF files, you can kind of describe to it how you would like to parse a PDF into this new document format. But for now, we're just going to use text. So they have something called a text reader. They have all these readers. So they have a text reader and a JSON reader right now. But we'll be the text reader. And the text reader, you just give a hook to the resource, and you let the reader read it. We'll add all of whatever the text reader reads into our documents array. So now we have a list of the Spring AI documents. Now we need to store those documents into our vector store. Now we don't have a vector store yet, so let's go build one. I'm going to build a new bean, and I'm going to stick it in this file for now, just so we don't get a circular dependency. So you can declare a new bean. At bean, we'll put a static, like a singleton reference to this class in the bean pool, so we can just inject it on the other file. So we're going to make a public simple vector store. And what this is going to take is an embedding client, and we'll describe that in just a sec. New simple vector store embedding client. So what this is doing is setting up a vector store that we can inject anywhere in our application. It takes in an embedding client, and an embedding client is very similar to a chat client. So previously when we're chatting with the models, right, we do a chat client, and we can chat. An embedding client talks to the same models, but it does embeddings. So it'll call out, it'll give it some text, and it'll give back these giant arrays of floats or doubles. And so that's what the embedding client is doing. So the simple vector store has a hook to the client, so when we ask to add things to the vector store, it can use that embedding client to make calls out to OpenAI or whoever we're talking to get all those embeddings. So now that we've got a simple vector store, we can go back to our REST controller here, and let's inject it. Private final simple vector store, simple vector store. Okay, so now we should have a hook to that thing when the app starts up. And we can use simple vector store.save. Oh, no, not save, sorry. Add. And we want to add all our documents. All right, simple. Next, we want to persist to a file. And we're only doing this really for the purposes of this demo so we can look at it and I can show you guys kind of what's inside of that. So if we do simple vector store, if I could type .save, we need to give it a file resource. Again, Spring makes this very easy. We can make a private resource vector store resource. We can give it a value, and we'll just say you are located on the class path at slash, oops, if I could type, vector storage slash vector store JSON. So I have this empty JSON file here. There's nothing in it, but that's where it's going to reference and kind of override the contents of it once the app starts up. And so now that we've got a hook to this file resource here, we can do vector store resource dot get file, and now we're persisting it. So that should be pretty much it to get the embeddings created. So let's start our app back up. It's kind of a lot of code, but really it's not a ton. Find a whole bunch of files, convert the files to a different format, save them. Relatively straightforward. Okay. Let me go find our file here. And remember, we're not at stats, we're at slash embeddings. So let's make a post and see what happens. All right, we got a 200 back. That's always promising. And let's look at our terminal. You'll be able to see on our terminal here, we get a whole bunch of, hey, vector store, we're calling embedding client for a document ID, calling embedding client for a document ID. So that's it, looping through all of our markdown files, all of our stats, sending those off. And what we should be able to see, if we go look at our build, our resources, our vector store, this JSON file is populated with a whole bunch of data now. What I want to show you guys is kind of how this is broken down. So for the in-memory or this file-based vector store, Spring's got it set up to where you have like a unique document ID. So each of these chunks of the JSON is a document ID. The content here is going to be the contents of that markdown file. So for example, here you can see this was our field goal information. And so this is the contents of the field goal information file. And then you get your embedding. And your embedding, like I was saying, is these giant arrays of numbers. And these are the dimensions in your vector store where it's going to get stored. We send this giant content string off to the model, and the model responds with the embedding. This giant embedding, and you can see they're pretty long. Anyway, so that's, as an application developer, I am happy I don't have to know how that works, but there's a lot of math and a lot of magic behind the scenes that gives you these numbers, but it's very easy for me as an app developer to not have to care too much. As long as I have a vector store and I've got an embedding, I can insert it into my vector store, and it's good. I can reference it now. So that's how the embeddings get generated. Now let's use them within our app. So generate embeddings, we're kind of done with you for now. We can create our database, we can populate it, life's good. What we need to do on the other side is when we get ready to send it off in the system message, remember we've got the format and all that stuff here. We also need to send the documents. So what we're going to do here is say utilize information found in the documents section to answer any questions you don't know. And we're going to put documents here. All right, so how do we get these documents? Again, we're going to use our simple vector store. We're going to get a list of documents, simple vector store dot a similarity search. So we're going to perform a similarity search with the request.question. So what this is doing is we've got that big file with all the documents and all the embeddings in it. What this is doing is it's taking the question we've asked. So the question we're going to ask it is about defensive tackling. And what it's going to do is it's going to send that request question off to the model that we're talking to, and the model is going to give us an embedding back. So we already have a vector store full of embeddings, but we're going to get a new embedding that's associated with the question. And then what we're going to do is a similarity search. And so we're going to try to find the documents that are most likely going to be that are related to the question I'm being asked. So that's what is all happening behind the scenes here. Again, as an app developer, I don't have to care how it works as long as it gives me the right info. So I'm going to get the documents, and then we're going to turn them into a string of like document text, and we'll say documents.stream map document get content, and we're going to collect them together with like a, if I could type, like a /n just for new lines so we can see it. All right, that's it. We ask our vector store for the documents. We convert all those documents into a big block of text that we're going to send along in our request, and we're going to pop it in right here. Document, what did I call it? Documents. Document text. Awesome. That's it. So if we start it back up, what we're going to do is repopulate our vector storage first with the embeddings call, because this is it's stored, it gets cleared out on every run the way that I've got it coded up right now. So let's generate our embeddings. Those are created. We've got them in here. Life's good. So if we get rid of embeddings and we ask it for the 3 leaders and total tackles for Hawkeyes in 2023, hopefully we'll see that we get our 3 individuals we had talked about earlier. Look at that. The Iowa Hawkeyes, we had Jay Higgins with 155, Nick Jackson with 99, and Sebastian Castro with 61. Super cool. So if you go look at the terminal, again, we kind of go back to these prompts that we keep sending, and you kind of saw it a little bit there. Back at our prompt, this is our new stuff that we added. Utilize the information in the documents section to answer any questions you don't know. And so by default, I think Spring finds like 4 similar documents. The first document it found was like wins and losses. That's not necessarily related to what we wanted to ask about, but that's what was included. The next thing is about rushing yards. And then the third one we found here, this is the info we cared about. And what's crazy to me is the model's smart enough to know what TOT is, T-O-T, total tackles, and it's somehow smart enough to know this is a player name. So it's, again, there's things that surprise me that are crazy here, and this is one of those. Is like somehow I can send this text out, I get TOT, It magically knows that tote is total tackles. It knows Jay Higgins is a player name, and it can magically associate 155, 99, and 61 with the right people and send it back to us. Again, if you don't do RAG and you don't do retrieval augmented, it's not going to know this information, but this is kind of how you're going to want to do things. If you want to write an app that, parses your Confluence docs or parses your internal support documentation, that kind of stuff, RAG is really good about. And what's awesome is you take your info, right, and you send it off to these models, and the models are just so stinking smart that they magically can parse things together like this. And it's super, super cool and hopefully exciting. Again, so this has been Kyle Haynes with Technically Speaking at Source Allies. Do you have a topic that you'd like to see us cover? Comment it down below or check out sourceallies.com to learn more about us. Thanks for watching, and we'll see you next time.